I'd like to introduce to you two ideas through an example, mixed numbers and improper fractions, and how we can go back and forth between the two. So I have an example of a mixed number being 3 and 4/5. It's a mixed number because there's whole parts of the number and there's fractional parts of the number. Want to convert that to an improper fraction. And an improper fraction has where the numerator is greater than the denominator. The process that we do that, I'm going to explain it two different ways, but the algorithm that some of us might be comfortable with or remember does this. We take the denominator, multiply it by the whole part, add the numerator, and divide by the denominator, where that equals 15 plus 4, which is 19 over 5. And then 19/5 becomes my improper fraction. Now this isn't reduced or simplified, it's only converted from mixed numbers to improper fractions. All right, nice algorithm, Willie. I can learn it, and I can do it, but what in the world does it mean? Well, let me try to give you an idea of what it means. Imagine that I have 3 parts, for example, that are all divided into fifths. Yeah, good luck trying to make a fifth of something. There's a pie divided into 5. Another pie divided into 5. Another one divided into 5. And another one divided into 5. So imagine then that I have this first one right here, and I have all pieces colored in. So I have one whole piece, and I have 5/5 of it all colored in. Likewise, that's all colored in. I have another one whole piece of 5/5 colored in. Likewise, one whole piece, 5/5 of it colored in. And the last one, I only have a fractional part of it colored in. I only have 4/5 of them all colored in. So I have 3 whole pieces and 4/5 of a piece. The 3 means I have one whole plus another whole plus a third whole, which makes 3 wholes. 3 wholes of 5/5, 5/5 plus 5/5 equals 14/5. So how many total do I have colored in for the entire 4 pieces? 5 plus 5, 10, plus another 5, 15, plus 4 more. I have 19 total pieces, all that were divided into fifths, which gives me that 19/5. So visually what's happening is this 3 represents the number of whole parts. So I have 3 whole parts plus 1 partial part, which gives me my total improper fraction. So visually, this is what we're doing. Algorithmically, we're taking the bottom times how many total parts, 5 times 3, 5 pieces times 3, adding the 4 remainders all over the fractional part of each one of those. So this is an idea of how we can go between mixed numbers and improper fractions. This improper fraction too, we need to understand that 19/5 is also a division problem. That's 19 divided by 5. And so we're going to get the idea that when we see fractions, we're also going to know that it's a ratio. It's also the division type of an idea as well, and we can convert going backwards just as easily. I can take 5, divide it into 19. 5 goes into 19 3 times, and I have 4 remainder. So I have 3 plus 4 parts of 5 remaining.